Hello friends, welcome to Coding Tutorials channel. Hope you are doing great. Today we are going to discuss another problem from Leetcode. I have uploaded the code for this particular problem to the GitHub repository. You can get the link from the description below this video. Also, I have created bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, and linked lists. Please take them out. So let's get started with today's problem. Minimum elements to add to form a given sum. You are given an array nums and two integers limit and goal. The array nums has an interesting property that absolute of nums of I is less than or equal to the limit. Return the minimum number of elements you need to add to make the sum of the array equal to goal. The array must be containing its property that absolute of nums of I less than or equal to limit. Note that abs of x equals x if x is greater than or equals 0 and negative x otherwise. So that's a definition for absolute of x, which we know already, right? Simple. So basically what that means is, so let's say if you are looking for absolute of 4, let's say, right? So that is essentially 4, right? But if it is absolute of minus 4, right, that will be 4, right? So that's what it is going to be, right? Simple. So whenever you have any number less than 0, the negative sign will be taken off. That is the value of the absolute value of the negative number, essentially, right? And so we are given with two things, right? So limit and goal in addition to the array of numbers. So the input is basically array and limit, right, and goal, right? So these are the three things that we are given in the input. So from that, what we can get is from the array, the limit. Basically, there is a property, right? Absolute of any number within the array will be less than or equal to the limit. So let's go ahead and look at the example one, right? So basically, this is the nums. Basically, the numbers can be repeated, it seems, right? So one, negative one, and one, right? And the limit is 3. So that means any number in the nums array should be, the absolute value should be less than or equal to 3. Yes, so 1 is less than or equal to 3, and negative 1's absolute value is 1 again. 1 is less than or equal to 3, and again 1 is less than or equal to 3. So all of these numbers are essentially less than or equal to 3, right? But how many elements that we need to add to this array to make the goal as minus 4? The goal is what? The sum of all the elements in the array. So what is the current sum here? So 1 minus 1 is 0, plus 1 is 1. So the current sum is 1. But we need to make this current sum, basically the sum, to come as the goal negative 4. So how many minimum number of elements that we can add? So, but there is a condition that we need to really satisfy, right? So we have to keep maintaining the property as absolute of nums of I is less than or equal to limit, right? So that means we need to add the numbers which are less than limit. So what is that less than limit? When we say absolute value, right? So that means minus limit to plus limit. So this is our range, the elements we can add to the array, right? This makes basically the absolute of that number will be equal to less than or equal to limit, right? So our number criteria will be negative limit till limit. So that means here for the example one, if we translate this, right? So the numbers that we can select is minus 3, minus 2, minus 1, 0, 1, 2, 3. So any of these elements you can add to make the goal as minus 4, so that you pick the elements from this range, right? As we said, minus limit to plus limit, right? That means the absolute of that number will be still less than or equal to limit, right? That's the condition that we need to essentially satisfy. So for the example one, the numbers that we could consider are only from minus 3 to plus 3. Is that clear? Okay. So Now, out of these, so the current sum is what? 1 minus 1 is 0, plus 1 is 1, right? The current sum is 1. That's what we said. And what are the numbers that we could add to make it minus 4, right? That's the thing. How many numbers that we could add to make it minus 4? So current sum. So current sum, since I already have, let's say current sum is the sum of the all elements in the array. That is 1, right? So how many number of elements we can pick to make it as so our goal is make the current sum to goal, right? What is the goal? Minus 4. So what numbers we can add to make 1 to become minus 4? So we can keep on adding minus 1, minus 1, minus 1, minus 1, minus 1, right? So if you add these many minus 1s, right? That means the 5 numbers, right? 5 numbers, essentially, right? So your cursor is 1. You know how we got, right? Just add all the elements in nums. That's what is cursor. But our intention is to transform this current sum to the goal, which is minus 4. So keep on adding negative 1s. So if you add 5 times, right, negative 1. 1 minus 1 is 0, minus 1 is minus 1, minus 1. If you add minus 1 to minus 1, it will be minus 2, plus minus 1 is minus 3, plus minus 1 is minus 4. So that means you are essentially adding 5 numbers to make it a goal, right? But what is our intention? To get minimum elements, right? So we are looking for minimum number of elements, right? So that's the ask here, minimum number of elements. So this could be taken as maximum number of elements, but even this is not a maximum number of elements, right? So the maximum number could be infinity, basically here. You keep on adding zeros, right? So just add 0, add 0, add 0, add 0, and so on, right? You don't need to care about this. You can add whatever that is, right? It doesn't matter. So essentially, you could add infinite amount of numbers to make it as minus 4. But out of that infinity, the 5 numbers are negative ones. But is that the right answer for this? Right? So we are looking for a minimum number. So this would be actually, if you consider without the zeros, 5 would be the maximum number, right? So of course there is infinity if you add like infinity number of zeros, right? But coming back to non-zero numbers only, so the 5 will be the maximum number, right? But what will be the minimum number? How do you get that is the question, right? So by looking at, so if you just add minus 3 and minus 2, for example, right? So you have cursum is 1. If you add minus 3 and minus 2, these two elements, right? Then you would obtain the sum as minus 4, right? So that means the minimum number of elements that you need to add to the given array to make the goal as minus 4 is 2. So you add minus 3 and minus 2. That's good. But how we are going to generalize this problem is the question, right? So we are going to follow the concept that we discussed and frame an algorithm around it. Okay. So now we are going to calculate the cursum as is. So our cursum will have cursum value, right? And then we will have something as difference between the cursum and the goal, right? So goal we have, and the cursum is what? The sum of elements. Let's say sum of numbers, right? So that's what we'll call, right? And you have difference between cursum and goal is as diff, right? So let me take as diff, right? Just in case, not not to get away from that, right? So now, so the current sum, that means the sum of the elements could be negative or positive, right? But it so happened that in our example it became positive, right? And the diff is cursum minus goal, essentially, right? So we will say or goal minus cursum, whatever that is, right? Cursum minus goal, that is a difference, right? That's what we are going to. So cursum could be negative or positive, and even the diff could be negative or positive, right? But what are the elements that are in question that we are going to add? only from negative limit to positive limit, right? As we discussed, for example, -3 to +3, right? That's our element range that we can pick and choose and play with to come up with the minimum number of elements. But do you have to really play with the all the numbers, all starting from -3 to +3, or is there any better way? Since we are only cared about the absolute of the number, right? So what I'm going to apply a technique is, since this difference and cursum could be negative numbers, what I'm going to do is, if diff is a negative number, take the absolute value of diff. So take absolute of diff, right? So that means, as we already discussed, absolute of a negative number, we are going to drop the sign and that will be the positive number. Just like in the example, absolute of -4 is 4, right? So take the absolute of diff, right? That means if diff is negative, this is negative diff. That means it will become positive. If you apply negative on a negative number, it will become positive, right? Likewise. Simple. So now you have a diff. So from the diff, keep on subtracting the maximum possible number. What is the maximum possible number here? Is limit, right? Only the limit is the maximum possible number. Although we are saying negative limit to positive limit is the range, right here. But what is the possible number for the maximum? It's only limit. So keep on subtracting the limit from the diff, right? And keep track of a counter, right? So in this case, diff minus, so diff will become diff minus limit. 1 second, limit. And our counter increment to 1. So we will be doing this basically so many number of times. But how many number of times that we are going to do? So and so on, like that, right? How many times we can do this? As long as diff is greater than or equal to limit, right? So we will have to do these many operations as long as uh, diff is greater than or equal to limit, right? If diff is less than limit, obviously we cannot subtract limit from the diff. So here I am talking limit, right? So when I'm talking limit, right? So the limit is always a positive number. So that means what we are essentially doing is we are subtracting this positive number limit from the diff so many number of times. And as and when you subtract, you are going to increment the counter. But what if there is a place that you are in this condition, right? Diff is less than the limit, right? What if diff is less than the limit? That means we will have to subtract 1 from limit. That means we will be limit minus 1. So what we are going to do is diff is equal to diff minus limit minus 1, right? And simple, we will be incrementing the counter, increment the counter, right? So you do go on doing this, right? So you do this again how many number of times that you have, right? As long as, again, how many times you do it, as long as diff is greater than or equal to limit minus 1. Remember, we already subtracted 1 from limit, right? So how long you will do this, right? So limit minus 1, and then after this you go limit minus 2, limit minus 3, so on, right? But how long you are going to do it? Till the difference becomes 0, right? That's what our goal is, right? What is the difference essentially? The difference between cursor and goal. As long as difference is greater than 0, we keep on doing this. Either subtracting limit or subtracting limit minus 1, limit minus 2, limit minus 3, so on, right? Like that. So we will continue this process so many number of times, right? There is one optimization that we can do, right? So we'll come to optimization. We're going to go through the code in a second, but there is an optimization that we can do. Since we have been subtracting the limit so many number of times, right? Do we have to really loop through this and do it? No, we don't have to do this many times of looping. What we can essentially do is just uh, divide the diff by limit, right? Divide diff by limit. So you will know how many times you need to essentially subtract the limit from diff. That will be that many number of times you are going to add to a count, right? So we will say this is the times, right? That many times you are going to subtract limit from diff. So in that sense, what we are going to do is counter is equal to counter plus times, as simple as that. And then the ultimate value for diff will be diff is equal to diff minus how much it will be, times into limit. So because that many times we already subtracted, right? This is the optimization that we can do instead of doing the subtraction so many number of times, right? And again, this will remain same anyway. So if you are not able to subtract limit from diff, right? What we are going to do is decrement the limit and see if you can subtract limit minus 1. If you cannot do, subtract again 1 from limit minus 1. That will be limit minus 2, so on. So at the end of all that, right, you will do that till difference is greater than 0. As long as difference is greater than 0, you'll keep on doing subtraction, right? Finally, whatever the counter that you have accumulated, that will be our answer. That is the minimum number of elements, right? That's it. So let's go ahead and look at the code, right? So we will be following the similar things basically. So cur sum is just the sum of the numbers, and then counter is initialized to 0, and you calculate the difference between goal and current sum. And this one, if the difference is less than 0, I'm taking the negative difference or just difference. Basically, you could take the absolute of difference too, right? So if you are really worried, so just take the ABS of diff. That's also works, right? So diff is equal to ABS of diff. It works, right? And this is where we are entering the while loop. If while diff is greater than or equal to 0, right? While diff is greater than 0, right? If it is 0, we get out of this while loop. We don't have to do it, right? Because we already added that many number of elements already. So now, if diff is greater than or equal to limit, right? That is when we will be able to do the division, right? Remember, if diff is less than limit, we won't be able to do any division. But if diff is greater than or equal to limit, we will be able to do the division. So the division, we are getting the times, just like how we discussed, and we will be adding that the times to the counter, and then subtracting the limit into times from the difference. So the difference is subtracted, right? But otherwise, what we are going is just decrement the limit and continue this process, right? Simple. So finally, whatever the counter that we have accumulated, that will be our answer. As simple as that. So the problem when you look at it, right, it looks like very much complicated. But when you once you go through the understanding process a little bit, just like how we went through here, how many times we are subtracting the limit from the diff and all that stuff, we can do some set of optimizations, and the code is pretty simple now, right? So all you're doing is just get the sum and then calculate the difference. As long as the difference is greater than 0, you keep on subtracting the limit, right? So if you are not able to subtract the limit, just decrement the limit and see if you can subtract. Decrement the limit and see if you can subtract. You do that as long as the diff is greater than 0. Simple, right? So now let's look at the time and space complexity. Time and space, right? So time and space complexity will be very tricky here, right? Because I think time is tricky here. Space is straightforward, right? So let's look at the space first in order to understand, right? So are we using any additional variables here? So we are using a cursor, that's a variable, and count, another variable, and the diff, right? So apart from that, we are not using any storage, right? So whatever the storage, apart from those three variables, we are not using any other storage. So that means the space would be, we can say, constant space, which is represented by order of 1. So it's constant space, right? So we'll just say constant space. Good. Now come back to the time complexity. So let's go step by step. So this one, we will assume n elements in nums, right? There are n elements in nums. Good. So if there are n elements, this would take, right, order of n, right? This would take order of n because we are going through the entire array and to get the sum, as simple as that. Good. And do we have any information how many times this while loop will be executed, right? We actually don't have any information about how many times this could be executed. So in the best case, it could be zero. It could be zero, right? So what if the goal in this particular example one is one, right? Then you don't have to go through this at all, right? You just count it zero. We don't have to do anything. So that's the best case. But what is the worst case, right? So you might have to add m number of times, right? M number of times. So the diff will be calculated whatever the limit number of times. So that would be equal to how much? Let's call it as m, right? So that would be equal to m. Let's say there are m elements we need to add, right? We need to add to the array so that we get the goal, right? So in that particular sense, what we will say is order of m, because m is unknown and we cannot specifically derive it from here. We will say order of m, where m would be the minimum number of elements that we are trying to add, right? As simple as that. So that is the upper limit. So is that clear? Order of m will be the number of elements that we are going to add. That's why I'm saying it's order of m to give you the better understanding, right? That's the minimum number of elements that we're going to add. Given that we are not going through the m times loop also, right? So even though there are like for this example, right? So I have a very good example here actually. 5, 6, 4, 5 and a 6, right? Out of this, the expected is like, okay, uh, 9 billion, something like that. So 982 million or something like that, right? So that many number of times that we are giving as the upper limit. But as we did optimization, right? So we are doing the optimization as times is equal to diff by limit. So we have reduced this time from order of m to how many? Order of log m, right? Since we are subtracting, subtracting that many times. So, but in any case, if all of those are what kind of elements? In a decreasing order of elements, then we will say order of m. So that's how we will be defining the time complexity. So for now, we will say order of m will be the time complexity, which will be the minimum number of elements to be added, right? So it will be roughly equals, but it is not exact. Again, please keep that in mind. Okay. So if you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. You can find the code for this in the description below this video. I will I'll be back with another problem very soon. Till then, stay safe and goodbye. Thank you.